Hi, we are Team 90. Let's start our progress presentation. In general, many studies of neural machine translation have been conducted to improve the quality of translation. In that cases, neural machine translation models generate similar results. Separately, however, some studies are ongoing to increase the diversity of translation while maintaining the quality. So we focus on this, diversifying translation results. The generation of various translation is largely helpful in two ways. First, this can use for text data augmentation. We can collect language data more enriched than simple data augmentation by translating English large language data. And second, it can provide users with various translation options. For example, users may desire to obtain multiple translations, or if the language learning system can show multiple sentences with the same meaning, learners can effectively learn a language. There are three main ways to increase the diversity of translations that are improving the coding algorithms or varying a hidden representation or using sentence code. Among these, the method to improve decoding algorithms could generate diverse translations while keeping the quality. We can also try various experiments because this method minimizes model training costs and changes only the decoding algorithm. Thus, we picked this paper as our application and picked two papers representing the other two methods as our comparison papers. Now, let me explain briefly our application paper. Authors assumed that certain words of a source sentence were assigned to each attention head. Thus, they thought that the model can generate diverse translation by changing the assigned attention value. Based on this assumption, their approach started from selecting one of the multi-head attention used in the decoder of transformer structure. They assigned the entire attention head values as the same value of picked attention head by their sample policy. To sum up, the sample policy is randomly selecting one of the 8 attention heads. By doing so, their approach could generate diverse translations by changing the original value of attention. Also, they tried to augment the training data by using back translation. However, we think that their sample policy is likely to ignore the important information stored in each attention head. Their approach may increase diversity, but may cause the lower relevance of translation. Therefore, we want to generate diverse translation with keeping relevance of translation more by adjusting the sample policy. More detail will be explained later.
We plan to use WMT14 English to German dataset for translation. Out of many datasets used in the replication paper, we plan to only use and test a single dataset in order to save time for pre-processing and training, and thus run as many iterations as possible within the remaining time. For evaluation of back translation, we use WIT3 English to Korean dataset. This is a dataset which was not used in the original paper, but we are using it because the original dataset used in the paper is not publicly available, and Korean is a familiar language to us. For evaluation, we use 3 common metrics as follows: DQ, Rouge, and perplexity. As the first evaluation metric, we will be using DQ. We chose this metric because diversity is the major goal of our project and quality is a factor that cannot be compromised. DQ allows us to take both diversity and quality into consideration. 2 factors are involved: pairwise blue, which accounts for diversity, and reference blue, which accounts for quality. Then we will be using Rouge as another metric and measure both precision and recall. We chose Rouge as another metric as it is a complementary to blue. Lastly, we will be using perplexity as a metric which can measure how well the language model translates a sample. Perplexity is simply an inverse probability of the test set normalized by the number of words.
Let's move on to replication result. As we said earlier, we collected the WMT14 English German data set as the training set, and we applied the sentence piece with BP model type to segment the sentence and limit the vocabulary size to 32,000, including the special token. And before replicating the result of diverse translation, we have to produce the baseline translation result. So to implement the baseline model, we refer the transformer code implemented from Harvard, and we implemented the sample policies that was the main contribution of the replication paper. And all of the implementation codes are publicly available on below GitHub repo. And we faced some problems that in the paper there were no detailed information of experimental setting, such as batch size, maximum length, and setting up early stopping and so on. So we sent an email to the author of this paper. So we set up the model configuration like this. There are 6 layers in encoder and 2 layers in decoder. And in the training process, we adopted early stopping, and it took 2 hours per epoch. So it took about 21 hours for full training. And this is our experimental result. First, in quantitative analysis, we adopted 5 different metrics to assess the generated translation at content level and diversity level. And as we said earlier, we first tried to replicate the result of baseline, but our baseline did not reproduce the baseline result with large gap. And second, in qualitative analysis, we present the generated translation result to assess the quality at content level and diversity level using the beam search algorithm. So as you can see here, the majority of translations generate words with similar results, such as president in German, and the generated translation are generally short. So we thought that we need to make our baseline model converge to local optima. So we modify the training procedure, or we apply other smoothing function in the blue metric. And after that, we will make the experimental result as close as possible to the original result.
Our first line of improvement focuses on the sampling policy of the attention heads. So currently, if the heads focus on different words, the model randomly samples a head and copies its value to all the heads. So the random sampling here leads to increased diversity. But the issue here is that if the sampled head actually had the least influence in the decoding process, then we might not be able to guarantee the relevance of the output sentence. So our solution here is to sample from the heads that point to the most referred word, and the assumption here is that these heads have higher influence on the decoding process. Of course, we'll analyze the results and check if it's really the case. And the follow-up issue here is that it might lead to less diversity, as we're only sampling from the specific set of heads. So we are thinking of another solution of using the multi-armed band algorithm. So we haven't finalized the design yet, but we'll design the reward function in a way that targets both relevance and diversity. And our second line of improvement is to apply sentence codes to the current model. And this is from another comparison paper, which uses the sentence codes by conditioning the code and determining the syntactic structure of the output sentence. So we are also going to use the same approach to our current model to see if it really increases diversity of the output sentences. And here's our brief progress. And we are currently working on implementing the comparison papers, and we're also working on improving the model on the 2 ways we mentioned before. And this is it for our presentation.